That we know more of, at least certain types of black holes. We know that when very, very large stars end their lifetime, they form a very large core of iron and nickel. And that iron core can contract under its own pressure and become big enough and dense enough that nothing can stop the contraction. And the end result is a black hole. So it's thought that at the very last stage of a very massive star's life, you can form a black hole. So black holes are important for two reasons. One is they're a region where the force of gravity is extremely strong, and so they're a good place to test interesting and odd properties of gravity when it's very strong. They're also important because they are the end states of these massive stars, and so if you want to understand the types of things that are around in the galaxies, you have to know something about black holes. Black holes really don't do much, in the sense that a black hole by itself in space with nothing falling into it does not do anything in particular. It just flies through space. Black hole, if you're far away from a black hole, it just acts like some object with the same mass. So for example, it's possible to just orbit a black hole and have nothing happen to it. If you happen to become very close to the black hole, there is a region inside of which the gravity is so strong that there is no way to get out. So in that sense, black holes can capture things that happen to stray too close to it. But they don't actively reach out and grab things. You have to be already going into the black hole. So the event horizon is that region where signals cannot escape. Since light is the fastest thing we know of, there is no way for any signal from anything that's inside the event horizon to make it out. So you can think of it as this is the point at which the last communication from something that's falling into the black hole can be possible. Things that go inside the event horizon are beyond your horizon, kind of the way something that's a ship that's sailed far enough away from you, you can't see anymore because it's beyond the horizon, with the one exception that for a black hole there's no sailing back. So we know of several candidate black holes that are the sizes of large stars, so about 10 times the mass of the sun. And the closest of these that we know of is a couple thousand light years away. We also know that there's a giant black hole whose mass is a few million times the mass of the sun, about 20,000 light years away in the center of the galaxy. We don't know what the closest black hole to us is, because a black hole floating through space would not have any particularly noticeable interaction. So there might be black holes that are closer than a few thousand light years, but there are none close to us, none in our solar system, for example. So black holes, when they were first discovered, were expected to always only grow, because it was expected that nothing could ever escape a black hole. More recently, in the 1960s, a new proposal was made that black holes could actually evaporate by emitting particles from the region called the event horizon, where things would disappear. And so black holes that were left alone for a sufficiently long time, where sufficiently long means several billion or many trillions of years, will slowly evaporate. And so that's how a black hole could die. We've never seen that radiation, so we don't know really whether black holes can die.